Yeah, so welcome again, class, to the second part of this very interesting, very exciting, very stimulating, very, I need some more words, this lecture, which Professor Arigbabu started on multiple regression analysis. You know that in the first part, we learned about in course now, the theoretical part. This second part is going to be really practical. It's going to give us the practical component of the multiple regression analysis discussion. So over to you, sir, Professor Abayomi Arigbabu.
Multiple regression analysis part 2. The objective in this case is that at the end of it all, participants will be able to compute. You remember I told you that's like I cut the something halfway. So compute multiple regression using SPSS. To use SPSS for some basic assumptions of multiple regression. You will see where you can actually click certain things in the SPSS statistics to check some of those assumptions we spoke about. Interpret output of multiple regression in SPSS, and then report output of multiple regression analysis. For us, probably this is the most important part of it now, for you to actually be able to do the computation. We have showed you the story behind it. So now you actually want to do it. So I want us to consider a situation whereby we want to investigate whether examination performance of students can be predicted based on gender, age, in this case I said subject combination of students in the College of Education. Now, those of us that are familiar with College of Education system, students always take subjects. You see somebody say, I'm studying biology and mathematics, or I'm studying geography and economics and so on and so forth like that. So the subjects, they combine together. We want to see, can it predict their examination performance, something like that. If that is what you are interested in, then you decide to use a regression analysis. Of course, we're now saying we will have probably checked all those conditions, and if you have not, like I said, you see in some of these areas how you can use SPSS to do that. In SPSS, there are always two views. One is the data view, and the other one is the variable view. Now, the one I'm showing you right now is the data view. So the data that you put inside, that you actually put inside, I'm sure you have had some lectures on how to code, how to put in data in SPSS. So in this case, I actually quickly went to one of the data that I have and wrote it out for the purpose of illustration. So, and I had to do screenshots, because what I actually wanted to do before was to do it hands-on. But I realized that there is still one other lecture session, I think.
Workshop.
Yeah, and that's where we will work and shop. I'm
yes.
sure Professor will provide what we will shop.
Oh, yes, of course.
So that place, I mean, probably we can actually have what I call hands-on. So instead of showing you all these screenshots. So this is data view. Of course, in this case, we have the matriculation number of students. That's what we call matric underscore n, gender, age, and so on. And then we have already put this one in there. Because of time, I won't go too much into it, but maybe during question time you can ask. You see, in some places I have -9 under the matric number. I will explain, if you remind me at the end of the lecture, during question time, why we have something like that. That's the data view. If you go to the variable view, in the variable view, it's like that's where you have maybe programmers or maybe computer scientists, they will say the back end. When you have, for example, if you are looking at a website of a university or something, you'll be seeing things that you can read. The back end of it, a lot of things go into it that you will not be. So this is like the back end. That's the variable view, where the variables, all the variables will have been defined in one way or the other. And I'm sure we have had lectures on them how to use SPSS basically. So that's the variable view. Now, in this case now, having put in your data, you now go on to analyze. If you look at the top, that is the icons that you have on top. That you have file, edit. Let me see if I can use a highlighter so that it will be good. So you can see that we have file, edit, view, data, transform, analyze, and so on. So most of the time, you come to analyze. Click on analyze, that's where I am here. And then you drop down with this one, then you go to regression. When you get to regression, you'll see that because it's showing an arrow here, it will also, something will pop up, pop out there. That's another drop down. So where you have that drop down, you go to linear. Regression, linear. I hope we are following. I don't want to be too fast because I remember Professor Kepukola reminded me that we have French speakers. So we are actually very poor in this thing. We don't learn French and we are not able to follow. But I'm really happy that these people can even speak better English than some of us. So you go to regression and then go to linear. So after that, please follow it. That's step one. Analyze, regression, linear. So after that, you move to the next slide, which is the linear regression dialog box. Because immediately you now click that linear, it will give you this box. This box, actually, I will have actually excised it out for it to be bigger so that you can see it. I deliberately, this is how it will appear on your screen. And I actually want you to be able to see it the way it is. We are going to do this one during the workshop. That's where all of us will have to bring our laptops out. And as we are doing it, we'll be doing your own. So that if you have challenges, you tell us, you raise up your hand and so on. I want to tell you, as a mathematician, I actually studied mathematics. In fact, I studied mathematics with computer science. And for us, we usually look at SPSS as, no, it's for, maybe it's for small boys. For mathematicians, we just look at something. The name is a statistical package for social sciences. I mean, those of us in science, but you say it's for social sciences. That time we were studying Fortran, Cobol, Pascal, Algol, all those big packages. But
those ones are gone. Those days are gone. Fortran, all those ones are gone.
Yeah, the days of Fortran, I'm sure you know that.
I did all of those.
Yeah, where we have to start coding and then you have to punch cards. You pack a lot of cards around. People know that. Thank God for the development technology. So now you say this is what will appear on your screen. After clicking, and I will remind you again, analyze, regression, linear. It will bring you here. From this screen, you will say that you have the column on the left where you have all those things you see. Actually, it's because of the data I've used, because the scale actually has some other sub-elements. So those are the things you are seeing. And then on the right now, you have the dependent, and then you have under block one of one, and so on. You have independence. Okay? Independence, and I'm sure you realize that it will have been, if it had been simple linear regression, it's just independent because it's one-to-one, one-and-one. But here now you can have many independent variables. So this is where your dependent variable will come to this dependent, and the independent variables will come to this independent. That will be our step 3. I decided to break step 3. So sorry, I hope we are not. You don't intend to sleep. But I thought that.
No. I'm just following because I have a studio at the back here, which I'm following with your system.
Thank you, sir.
Yeah.
So now the next step, which I said is step 3, I decided to break it into 3. I have what I call the 3A. This 3A, the 3A you have here, you see, that's where you now. Just a minute. I'm trying to. Something is blocking my view, but I know it's not blocking yours. So 3A here, that's where you transfer your dependent variable. In this case, is examination performance. It's actually exam. If I take you back to the first slide where we started the analysis, you see that the first one there, we have exam and some other variables. So you transfer exam to dependent, and then those other variables that we call the independent variables, we'll transfer them to the independent variables. So that is step B. In other words, you will see that exam is now there already. And you see exam sitting comfortably there under dependent. Now you go and click gender, you click age, you click subject combination. There are two ways you can do this. You either click gender, use this arrow here to move it inside the independent, then go back, click age, move it in, click subject combination, move it in. But for people who are lazy, like myself, what you just do is to press the control button down, click on gender, still holding on control button, click on age, click on subject. So it will align them together like that. By the time you come here and move, it will move the three of them once and for all. So in other words, if you even have up to 10 of them, you can move the whole of the 10 and just move it at once instead of doing it one by one. So that's what I call the 3B. The 3C, and of course, I'm showing you what will be appearing on your screen, on the computer screen. The 3C is to transfer. I've transferred them, which I've actually gone to do that. So the 3C is to I broke down to how you will click. That was my 3B. If you remember, 3B was where you click on each of them, and 3C is to transfer. You can see that I've transferred them, and they're sitting down here now. Now, the next step, which is step 4, is to now, where you have, let me take you back to step 3. In step 3, you see that's step 3C. You see that you have all this, and what's happening? I hope I'm the only one controlling this. Okay.
Nobody else can, sir. Except Madam is controlling you or something.
So like we said, so you see in step 3 that you see that you have nest. So when you click nest, it takes you when you have the dependent and the independent variables already inside there, then the next thing is to click on statistics, which I have there. You click on statistics, and then it takes you to this place. The statistic button gives you this linear regression statistics. You see this linear regression statistics that you have here. By default, you will see this tick where you have estimates, and you see another tick where you have model fit. Don't think that you are made a mistake. No, there is no mistake. It's like those ones are already there. So you can go ahead now to click on the confidence interval. Can you see now the confidence interval? I've clicked that one now. You have that one in addition to the estimates and the model fit that you had before. So, and you just leave it at 95% level. Don't give yourself any problem. Just leave it at 95% level. Okay? And then after that, I don't know what is happening. Something is affecting my mouse. Okay.
The wicked people are.
The enemies at work.
The enemies at work.
God is more than them. So
God
now you have
God's more than them.
confidence interval. Okay. So this is what you will see when you click that. You have this. Leave it at 95% level. Leave it as it is, and then go to the next one, which is step 6 now. Click on continue. That continue button that you have here, just click on it. Click on continue. You can see continue. When you click on continue, then you return to the education dialog box. So, and then you now click OK. So when you click OK, then you go ahead. Oh God. So now When you now click OK, you will have the output, what we call the output. That's what will appear. Like Professor Kipkola said the other time, all those, I think that it was last lecture, all those mathematical jargons that will scare you from using multiple regression analysis, SPSS or any package you use will do it for you in a matter of seconds. Before you even say your Jack Robinson is already there. Okay? So you see, this thing is actually in those days, it was a lot of hell to do all these computations, but we thank God for technology. So it will just do it in a matter of closing your eyes and opening. Before you open your eyes, the result is there. So this is what you have as output. Let me now try and go into them and let's see. You see this model, variables entered and so on, that variables entered, variable removed and so on. In this case, no variable removed and so on. But now going to the interesting part, that is the model, and you see the model summary. So now we are now going into interpreting and reporting the output. You have already gotten your output now. And that is the unfortunate thing at times. People will do very good work. They have a very good study, and they will now go ahead and give their work to one charlatan somewhere who doesn't even understand. The only thing that person knows how to do is how to code. And it will just code, and then it will run frequency, run ANOVA, do all sorts of things, whether it fits what you are doing or not. And then it will start things that he has had before, and he will tell you all sorts of things that this is. You can imagine, it's like going to a medical doctor, and you actually have maybe stomach upset, and then he decides to give you injection in the tummy, and then he decides to give you one in the head, and so on, when you have a headache. So that's the type of thing that people are giving you wrong prescription. So and then you are drawing wrong inferences. So but the beauty of this program is that you are being empowered to be able to handle your analysis yourself.
Correct, sir.
And then you'll be able to get the result of the study you have conducted.
Yes. Sir.
Sincerely, I think it was Dr. Ladejo, Mr. Ladejo, that asked the question the other time. You see, when I was doing my PhD, I actually did my PhD in South Africa, and I was in the school one day on a Saturday, and I was working. Then I found out that something has gone wrong. That this is how I went up this PhD. I now called my supervisor. We call. So it said that once you have it straightforward, then it is not research. It should actually be complicated, and that's why you are doing it. So and it's like go and sleep, and then start again. So that's just to tell you that it's not as if you are going to find it easy. At one point, you feel like abandoning it and running away. That why did I put myself into this trouble? Now people are locking down somewhere now, either with their wives or their friends and so on. But you are locking down inside your room. You are not able to access to some other thing. You will see the value of what you have done. In fact, if I have my way, I would have put in for a PhD in this program. And I don't think it is too late. I will say appeal to Professor Kipkola.
Okay, you're too big, you're my vice chancellor. Yeah. Thank you for your kind comments, sir.
So thank you very much. So it's a great opportunity, and I want you to make the best use of this opportunity. Just going on, like I said, this model summary. The model summary is where we are. Here, you determine how well the model fits. The table, I've extracted it out now to blow it so that you can see that I extracted it out from where it was. So it will provide you with R. It provides you with R. Let me get my highlighter again so that I can actually be pointing at it so that you'll see. So you have the R. You see the R square, the adjusted R square, and the standard error of the estimate that is used to determine how well the regression model fits the data. We'll go on to explain some of this. The R represents the multiple correlation coefficient. And that R can be considered to be one measure of the quality of the prediction of the dependent variable. In this case, dependent variable in this case is the examination performance, if you still remember. So it is that R is a measure of the quality of the prediction of the dependent variables. The value that we have, let me take you back to the table, 0.281. Can you see it here?
Yes, sir.
0.281, okay, represents, in this indicates a poor level of prediction. And I should also tell you this, which is very closely related to what I told you about my supervisor. I prepared for this presentation with the hope to give you an example whereby I will have statistically significant relationship, where I said predicted it well and so on, and I was so sure what I would do. So I just picked that data and I put it. It was only later that I realized that the one I picked, because I would have loved, Professor Kubukola would have told you this, or maybe some other people. When you have a situation whereby you are doing a study and you now get not significant. In fact, what they thought was that when something is not, why are you wasting your time? Just leave it. I mean, it's like you get to the market, you want to buy something, you say, "Mommy, should we buy this?" You remember that our wives were telling us, "Mommy, should I buy this in the supermarket?" Say, "You don't need it, leave it." So you just leave it, and then go ahead. So once it is not significant, most of the time it's like it just ends there and say, "This is not insignificant. Don't let us bother ourselves." So when it is significant, then you have to go ahead and explain a lot of things, and that's why it's always good to use an example where you have that, so that you'll be able to explain how to report it. But notwithstanding, in this case, because I felt that it was too late in the day, like Professor said, they won't admit me for the program, that I'm too old to start. So the 0.281 is actually too low. It's actually a poor predictor here. So look at the R squared. The R squared, also called the coefficient of determination, is the proportion of variance in the dependent variable that can be explained by the independent variable. It gives you an idea, that is of variance explained, what we call variance explained in this case. So you see that in this case we have 0.079. It's not 0.79, it's 0.079. So you see that this one is also not good enough. So in this case we have 0.079. So the 0.079 is like telling you, if you multiply it by 100, for instance, you now get 7.9%, something like that, 7.9% of the variability of our dependent variable. That is the exam performance. So this is definitely not good. So, and I now decided to, leave you with something. Unfortunately, we have opportunity. If you don't even do it now, we have opportunity to talk about this in our workshop. That how will you interpret the adjusted R squared to accurately report your data? I leave it for you to say something about that. Still going ahead, if you remember from that table, the next table you see, let me see if I can go back a little bit for you to see the entire table. The next one is what? The ANOVA. You can see, after the model summary, we have the ANOVA. So the ANOVA is what I have blown now up for you to see. You can see it here. So here, from this table, you see where you talk about the statistical significance. Statistical significance. So you can see the F ratio is there, which tells you whether the overall regression model is a good fit for the data. Okay, you can see you have the sum of squares, you have the residual, and so on, the regression and so on. So the ones that I've highlighted, you can see the mean square, you can see F ratio, and you can see the significance. Just like you have been told before, once you have a value like this, we usually compare this thing with 0.05. So when it is less than 0.05, then it is significant. But when it is above it, it is not significant. So this table shows that the independent variables did not statistically significantly predict the dependent variables. We usually write F, these three here. Look at DF. If you look at where I'm highlighting now, DF, that is the degree of freedom. This one we are familiar with it from other presentation that I have made. Degree of freedom here in this case is 3. But don't forget, therefore, so it's 3, and it's always n minus 1, number of variables minus 1, n minus 1. So you have 3, and then if you look at here, you have the 55 I'm reporting it. So you have F3, 55, 1.573. Well, P less than 0.05. I put NS in brackets, not significant. In most cases, once you just do that, you just forget about, there is nothing to really discuss. So the regression model is not a good fit. In this case, this one that we have chosen, unfortunately. But one thing I decided to do is to also show you how research, how you do research. You can see me, I think?
Yes, sir. Loud and clear.
Okay, good. So look at what happened to me. What I set out to do was to get a situation whereby I will have a relationship that will be statistically significant. Just for the sake of explanation, to illustrate this concept. Not that you deliberately go and look for that type of situation. So it's to tell you that at times you may even have a gut feel about something, that this is the way it is. You get to the field and it doesn't look like that. You now say, like they will say in Yoruba, you now change your change male to female because you have said that male perform better than females, and that's what everybody has been reporting. Professor Kipela reported it, Yuman Shabani reported it, all the bricks of this world, they reported it. You now say, you, a small boy, you now get the other way. No, I better, like I tell my students in those days, somebody was asked to write on the life and death of our Lord Jesus Christ. And he said, who am I? Yes, instead of asking the question,
I read about John the Baptist.
Writing about our Lord Jesus Christ. No. I'll take one of the disciples. I'll write on Peter.
Wonderful.
So you see, once you have any result, report it.
Report it.
You will be surprised that at times when Professor Kola did it, maybe it was 10, 20 years ago.
Sure.
When Nimik Briggs did it, our grandfather, maybe it was 50 years ago, or 100 years ago. So, report, things might have changed. Yeah. Today there is Corona.
Sure.
We are all logged in here. We are receiving lectures. It is different from the way we were doing things before. Nobody knew this would happen. So, if you have something that will have led to this, maybe if you have told us, we'll have all prepared for Corona, just like some people actually alerted us before. President Bush and President Obama. So now you see, don't be afraid to report what you get. That's what I'm trying to make. Yes. So you go to the next table. So I don't want to be going back of it. At least this is the next table there. That major one. I extracted it out. That is the estimated model coefficients. So this one, the general form of equation to predict the examination performance, which is actually a dependent variable, so you see it, the general form of equation to predict the examination performance by the IVs, something there. So is the predicted examination performance, you can see that. That's the equation that I try not to use to bore you the other time. So the predicted examination performance, it is 33.985. That is, the 33.985 is over there. Let me see if I can still get this highlighter. I don't know. It's not cooperating. So something must be...
It's okay. I'm highlighting it from the studio here.
Thank you, sir.
Yes.
So, okay, it's here now. I think, is it my own or yours?
Yeah,
it's mine, yes.
Yes.
It's mine. So I've tried to... So now, you see, can you see this 33.985? That is the constant. That is the constant term in the regression equation. So you see, predicted examination performance is 33.985, which is this one, minus, because in front of gender, you can see the portion that I highlighted in yellow. In front of gender, you see that you have minus 3.357. So that minus 3.357 is the one that you have next year, which is the one that you have next year, which is minus 3.5, minus 3. can you see that I use age twice instead of that is supposed to be gender? I hope you are following me.
Oh yeah, sure.
Yes, sir. Yeah, can you see the mistake there?
Yes, you can see. Yeah.
The age.
Yeah.
One of our teachers in those days when we were in primary school, their teacher was addressing us in the class and on the assembly, and he said, "You see, Jesus Christ died, was killed, and on the third day, he was buried. On the third day, he rise." Then we said, he said, "Okay, he risen." He said, he rose. Then he said, he rose. Then he said, so I can see that you are following. So
Yes.
now, you see, I should have, in that place, I should actually put
Gender.
Yeah. So please take note of that. I will correct it before we send it to you. So minus 3.57, that's in front, that's the gender. The highlighter has gone again. I don't know what is, I think it should have to do with the network. So gender, then you have in front of age, yeah, under this yellow highlighted portion, which is 0.551, and that's why we have 0.551 multiplied by age, minus 1.929 multiplied by subject combination. So that is the equation where you will have had beta naught or maybe alpha 1 or beta naught, which is the constant, plus beta 2 times gender, plus beta 3 times age, minus beta 4 times subject combination. So that's what we have seen. So those coefficients there, you get them from the unstandardized coefficients under B here. So that's one part of what we set out to achieve. Now, having done that, okay. So having done that now, we go ahead to okay. Having done that, we go ahead. Sorry, I didn't.
No problem, sir.
Yes. So having done that, we have the unstandardized coefficient. So the unstandardized coefficient. I'm trying not to go back to that table again because of the way this thing is made. So unstandardized coefficients, that one indicates how much the dependent variable varies with the dependent variable when all other independent variables are held constant. Professor Kola said something at the beginning. I don't know whether you still remember. At times you want to be sure what contribution each of the independent variables is making. Can you see that, please? You want to see you are under gender, age, subject. You want to be sure what the contribution of each of them is. That's under standardized. So you want to be sure of contribution of each of them. And in this example, you see that the coefficient B1, which is the minus 3.57 that we have in front of gender. Let me just take you back to the table. Can you see it? Minus 3.537. So what it means is that for every one point of increase in gender, there is a decrease because it is. You see that in this case it is a minus. So there is a decrease of 3.537 marks in the examination performance. So that is what that is trying to say. Just I give that as an example so that we can just move on. Okay, so we then go to statistical significance of independent variables. We can establish the statistical significance of each of the independent variables looking at the table. This tests whether the unstandardized or standardized coefficients are equal to 0 in the population. And if P is 0.0 less than 0.05, you can conclude that the coefficients are statistically significantly different from 0. You see, like I told you, this one is a situation whereby this thing, the independent variables actually do not really predict the scores very well. But notwithstanding, we have been able to illustrate how you do it. So when you have a situation whereby you have a good fit, you have good prediction from those independent variables, then you can just explain it the way I've explained. Now the t-value and corresponding p-value are in the under T, you can say T, here T, and then the under SIG. That SIG is actually significant. SIG means significant. So you can see where I'm highlighting. That's a T and SIG. So those two columns. So I ask you a question also here. In this case, are the independent variables statistically significant? If you look at the figures, I have answered it anyway, but I'm just leaving it for you. You can see when you have something either below or above 0.05, then you can answer it. I've already given you the answer to the question.
Yes, sir. 5 more minutes, sir. 5 more minutes, sir.
So I'm almost done.
Yes, sir.
So now the next thing after this is to just report it briefly when you now want to write out. Just report it that okay, a multiple after doing your study, a multiple regression analysis was run to predict examination performance from gender, age, and subject combination, and then you go on and on like that. In this case, these variables did not statistically significantly predict examination performance. Right? So Alibin is the one that actually predicts well, and then you just say, okay, these variables statistically significantly predicted examination performance. F these days, like I put 3.55, is equal to 1.573. I hope you you remember the F value.
Sure.
I don't. So don't let me go back to. So you have that, and then that will be the end. So in this presentation, we have used SPSS to compute regression, multiple regression. We have explained how to use SPSS. Well, anyway, this second one, we didn't really. I didn't emphasize it. While I was showing you some of those screenshots, there were places where you can check those texts. You can check some of them there, but I didn't remember to mention them. But we'll take care of them during the workshop. Yeah. Then we interpreted output for multiple regression, and also showed you how to report output of multiple regression. I want to thank you very much. And I want to wait for questions.
Wonderful. So, Joseph, you have the floor to ask your question. Joseph, we cannot hear you. All right, Ebisi, take the floor. We cannot hear Joseph. Ebisi, take the floor.
Oh, thank you very much, sir. I want to also appreciate the prof for making the regression analysis more simplified for us, sir.
Thank God.
One of the slides that was presented on the interpreting and reporting the output of multiple regression analysis. From the table given, we found out that where we have the table shows that the independent variable did not statistically significantly predict the dependent variable, where we have the degree of freedom between, which is a 3 and a 55, equals to 1.573. Now, the p-value on the table, we have the significant value, where we have 2.206. But from what is reported here, it says the p is less than. But from what we have here, the p-value is greater than 0.05. So
okay, thank you very much. Okay, Bugoma, you have the floor.
Okay, thank you, Professor, for the presentation. And for me, really, my fear in statistics was about interpreting data. Like when I saw the result, every time I was scared, but I don't know from where to start to interpret the result. Because sometimes you have many things, new things that you don't even know what they are, like what they mean in this table. So for me, I think at the end of this lockdown, I will have like zero fear in statistics.
Hey, wonderful. So thank you very much. Thank you so very much.
So
Frank?
My question
Yes.
is like about three things. Like what does residual reflects in statistics?
Okay, good question.
Okay, the second one is like what does standard error, because we know like standard deviation is like the way the data is deviate from the mean, but sometimes we see standard deviation error, what it does reflect in the table. And the third one is like confidence interval. Interval, I don't know how to say it in English. Interval de confiance. How it does reflect, what does this interval mean in statistics? Thank you.
Bugoma, I'm very proud of you. As you know, you are very willing to learn and you apply yourself to work. You are going to be a great professor. You know, what's your area of specialization, Bugoma? What's your area of specialization?
Regional integration and trade development.
Oh, wonderful. You are going to be the very best. And you want to be minister in Burundi so that we can just vote you in today so that you can be minister of rural integration. Oh, yeah. Okay, thank you. So, Franklin, you have the floor. Okay, let's go to Oladejo now. Franklin is not set. Oladejo, take the floor.
Thank you very much, sir. Thank you very much, Professor, for this one. Number one, you asked that somebody remind you about the -9 during question time. So I'm reminding you now about the -9.
All right.
That is number one, sir. Number two, for the sake of clarity, you said that because we had 0.281, that was a poor result. I therefore assume that is because 0.281 is far from 1. Because in the first edition, you said our value is between 0 and 1 for regression. I want clarity on that. Number three, if our result was significant, and you said we need to go further, like in Hanover, if it was significant, we then move to post-hoc. Do we have anything like that again in
multiple All right, thank you very much. Thank you very much. So that's fine. That's good. Sukomi, you have the floor.
Yes, thank you very much, sir. Yes, part of my question.
We can't see you, though. We can't see you. We can't see you. We can't see you.
Hello, sir.
Yeah, Sukomi, we can see you now. Please carry on. We can see you now.
Okay. Thank you very much, sir. Part of the questions have been asked by my colleague, particularly from the BC. So my first question now is, you have taken us linear regression and multiple regression. I just want to find out that the steps of on the SPSS, is it the same with both? My second question is that most of the value that they showed for us, the R square, and the adjusted R squares, are all written in 3 decimal places. Should that be, or because we have been taught that most of our reports should be in 2 decimal places? I don't want to write any story or book about the professor, but I just want to make clarification. Thank you.
All right, thank you very much. So if Joseph is ready now, we can take you. Or if Franklin, any of the two, within a few seconds. Okay, none. Now, before I yield to our professor and our vice chancellor, I'd like to really thank him for a point that he made. Professor Juma Shabani, Fred Awa, and I have been in the front line of efforts to address academic corruption in our universities. We are promoting academic integrity. And Fred Awa has done quite some work in this area. Professor Shabani has done quite some work in this area. And together we have done the three of us have done quite some work in this area. And the meaning of it is this. Please listen very carefully. If you are getting some results, just like our Vice Chancellor has just told us, you are getting some results, please report it the way you have found it. Do not cook your results. Do not go to a mercenary, okay, help me do this analysis, and the mercenary will say, okay, fine, I'm going to make it significant for you, because it's easy to do that. So you then get the printout, which is now going to deceive the world about the true finding. So whatever you get, if it's not significant, please report it. And if you look at our book on the CTC approach, there are some of the students that found, oh, CTC approach is effective in this context. CTC approach is not effective in this context. And I end up by telling you an experience. That was in 1982. In 1982, I was doing some studies on cooperative learning. That's 38 years ago. 38 years ago. I was doing some studies on cooperative learning, and I found the literature was conclusive. The literature was like nobody's run. You have to show that cooperative learning enhances students' achievement, and there is some brothers, Johnson brothers. They are the how do you call them now? They are the number one in cooperative learning, and they were reviewers for a journal. That's the number one journal in my field. Number one journal in my field, Journal of Research in Science Teaching. So when I got these results, I said, look, I mean, because nobody knows the ultimate truth. Everybody just searching for the ultimate truth. You don't know whether following Professor Shabani is the ultimate truth. You don't know whether following Fred Awa is the ultimate truth. So what did I do? I just say yes. I mean, although this is just running contrary to literature. I then sent the article to that journal, the number one journal in science education. And of course, one of the reviewers, the Johnson brothers, said, no, that cannot be it, and all that this thing. The other person, I had two positive reviews, and the Johnson brothers said, no, it has to be like that. It has to be that cooperative learning favors that. So they just sent it back to me to revise, and I told him very clearly that I was not going to revise, because the idea then would mean for me to cook my data, to say that, oh yes, that I made a mistake. And I told the editor that in this world, nobody knows the ultimate truth. We're all in search of the ultimate truth. How do you know then that cooperative learning, in my context, in the area that I've done it, will make it so? That editor accepted my article in 1983. It's published in this journal. This is the best journal in science education, number one journal. Journal of Research in Science Teaching. Let me see what I can say. Yeah, that's the journal. Number one, it was accepted there. Did you know that the following year, listen, the following year, when people saw that, because it means that some people have been finding out that in their context, it was not also helpful. It was culturally dependent. So I then began to see the literature come up with people now following me behind, running away from the Johnson brothers. So what we are saying here is what the Vice Chancellor has said. Our dear doctoral students in Africa, you are the best in Africa. Whatever you find, just report it. Don't cook your data. And in not doing so, don't go to people to be doing your analysis for you. They are going to cook it for you and mess you up. So that being said, let me now yield to our Vice Chancellor to take
Thank you very much, sir.
Yes, sir.
Yeah, I hope I tried to get all those questions down. Yeah. The first one that I was able to put down, I think she asked about why we have something greater than 0.05, and when I was reporting, I wrote P less than 0.5. You see, in reporting, that's P less than 0.05. That is the standard we have said. Remember, we talked about 95% confidence interval and so on. You are checking it against that. The P that you have there now is for the standard that I've set, which is the alpha level. That is 0.05. So that's what we are reporting there. I hope it is clear. And if it is not clear, definitely we'll have opportunity to. It shows that there are things that we need to emphasize maybe during the workshop. The other question asking about, I think the one asking about residual the standard error and standard deviation. I think you say, I think I'm correct. Yeah. So the residual error is a measure of the when you run multiple regression SPSS. So the residual error is actually an estimate of the variability of dependent variable unexplained in the model. Rather than confuse you, if you are not yet satisfied with this explanation, we will use it. I will prefer hands-on when we have the class. I mean the practical session. We can actually emphasize that.
Excellent.
Yes. Then the one by Saladego is 0.281. You have answered the question, and I want to actually commend you because you have been one of the very outspoken ones in the class. There's not any class you don't ask questions. If you look at, we say this thing range between 0 and 1. The midpoint is 0.5. So if you have 0.281, that is nearer to 0 than to 1. So the more this thing is actually definitely for you to start talking about whether it is good or so on, you actually have to go above 0.5, so upward. So when you now have it up, so then you see how good it is. So that's what it is. So you are right with what you said. And then you said when it is if it is significant, if we have reported statistical significance that we have a post hoc regression analysis. No, there is no post hoc. You know, the post hoc you do, and if you understand, and I am sure even from the question you ask, it shows that you understand what you are talking about. Why we perform post hoc in the case of
Hanover.
Hanover, and you see that you don't perform post hoc for t-test because it's just one variable. So you already know who is responsible. I mean, if you have two people in the house, this morning when I'm fasting, so we ate, and then it's not one bottle of water on the table, and then I said, okay, I take my own bottle of water. I said, okay, take this one. He said, I'm not going to drink it because I don't know who drank it. I said, well, okay, I know who drank it because I am here, I didn't drink it. You didn't drink it. This one didn't drink it. So definitely the only person that would have drank it is the other person. So once you already know the what is responsible, who is responsible for a crime, you don't go out searching again, doing any investigation. You just arrest that person straight. So in the case of the regression, you will see that we said one of the good things here is that to be able to establish how all those independent variables have jointly contributed to the prediction you are making, and how they have singly, when we say during award of degree, to say we are awarding you degree singly and severally. Yeah. So in this case,
well, one more minute, sir. We have to round up in exactly 1 minute, sir.
Yes, I'll round up. So you already know the contribution of each of the independent variables, and then the joint maybe the effect of all the three.
Maybe the other questions can come up during the workshop.
Yes, also established. At least then I think the one that is next is I've just about 2 more. Linear. Okay, about linear regression and multi. The one that we have done now, multiple. It's the same. It's the same way you go about it. So it's only that when you are putting in your independent variable, you only put in one instead of putting in so many in the case of multiple. So that's what we do first. And the reporting is also standard. Is about the same. 3 decimal places, 2 decimal places. You see, when you are not mathematician, some of these things you just it's not. This is not. Maybe if I have an opportunity to talk about numbers, one of these days, just to talk about numbers, there are things you know, but I will be able to talk about some of these things. 2 decimal places, 3 decimal places. I have reported those things. What we have there. There are standards when you are reporting. When you do study. In most cases, what you do is to actually use decimal places. But when I now have 2 decimal places on the table, I now go in and I start using 2 decimal places, and you start saying that, but this one was not there, and so on. So that's why I just put those things the way they are. Don't forget, I'm not writing paper. I'm actually explaining.
Exactly. Thank you so very much, Professor Abayomi Arigbabu. By the way, feedback have started coming in from our students, and they are saying that this is a very wonderful lecture that you need to read. I'm very pleased from this excellent presentation related to regression analysis. We really appreciate. These are things coming from the Burundi group. I can see quite a lot. Let's see. Yeah. That's it. I'm getting very interesting. Excuse me. Interesting feedback. So Tia is also confirming this feeling. So, Professor Arigbabu, we have thoroughly enjoyed this lecture of yours. I want to see whether Professor Dinola Anyolaja is still in the house so that he can make a presentation to you. Professor Anyolaja, let's see. Yeah, so I can now have the pleasure of Lagos State University Africa Center of the Africa Center of Excellence for Innovative and Transformative STEM Education, ACEITSE, World Bank supported project to certify that Professor Abayomi Arigbabu facilitated courses ACE 811-911 May 4 to 9, 2020. We'd like to thank you. We'd like to congratulate you for an excellent presentation. And I will unmute everybody so that we will all give a round of applause to our Vice Chancellor. Let's give a round of applause.
Very good.
Yeah, very good. Very good. Very